Now that we know how to factor polynomials, let's practice solving, first of all, quadratic equations by factoring. Now, what do I mean by a quadratic equation? Let's look at a definition. A quadratic equation is one that can be written in the form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is not equal to 0. Notice this is an example then of a quadratic equation. It is already of the form ax squared plus bx plus c is equal to 0, where a, the coefficient of x squared, is not equal to 0. As a matter of fact, in this quadratic equation, a is 1, b is 2, and c, this constant, is -8. But the important part here is to recognize this as a quadratic equation. Now, how do we solve a quadratic equation? There are many ways. One way is solving by factoring if it just happens that this polynomial can be factored. And we make use of what we call the zero factor theorem. It's based on the following. Think of any two numbers whose product is 0. Think of two numbers whose product is 0. Any two numbers. I know at least one of the numbers you're thinking of is 0, because the only way to get a product of 0 is if one or the other or both numbers are 0, and that's the zero product theorem, or the zero factor theorem. Let's look at that. The zero factor theorem, if a and b are real numbers, and if their product, that's a times b, is equal to 0, then a is equal to 0 or b is equal to 0. We're going to use that zero factor theorem to help us solve this by factoring. So to solve by factoring and to use the zero factor theorem, we have to factor or write this as a product. So let's do so. Let's see if we can factor this trinomial. Just concentrate on the trinomial. If this trinomial factors, because the coefficient of x squared is 1, I'm looking for two numbers whose product is -8 and whose sum is 2. Product -8 and sum is 2. Let's see, I do need an x and an x. That would be -4 and +2, or did I get that backwards? Let's check. That's x squared. The outside product is 2x. The inside product is -4x. That gives me a middle term of -2x or -2x, not positive, so I did get that backwards. That's a plus. And that's a minus. And now let's check. X squared, outer product is -2x, inner product is 4x, and -2x plus 4x is a +2x. Last times last, that's -8. So I have factored. Now to use the zero factor theorem, two things have to be true. One side of your equation must be a factored polynomial. This is factored, it's written as a product. The other side must be 0. That zero factor theorem only works when the product is equal to 0. I hope you can understand that, because what if I asked you for two numbers whose product is 20? Do you understand? We could all be thinking of different numbers, 4 times 5, or 2 times 10, or 1 times 20, or -2 times -10, so on and so forth. But if two numbers have a product of 0, it's special. One number is 0 or the other number is 0, which includes if they're both equal to 0. So we've got to have 0 over there to use the zero factor theorem. So what do? Once we have factored on one side, 0 on the other side, then we set each factor equal to 0. Since this is true from our original equation, then either x plus 4 is equal to 0 or the other factor is equal to 0. Now, if I solve this, I'll subtract 4 from both sides, and I'll have x is negative 4, or if I add 2 to both sides, I'll have x is 2. This equation has two solutions. One solution is negative 4, the other solution is positive 2. I'll let you check. We'll check one later on, but I'll let you check and make sure that those two are indeed solutions. There's no need to multiply this out, but if you looked on the left-hand side, if you did multiply that out, can you see that it is a quadratic equation? 2x times 4x, that's 8x squared. It is then a quadratic equation. Notice in this form, though, we already have a factored form on one side and 0 on the other side. So since I do have those things that are true, I can go ahead and use the zero factor theorem and set each factor equal to 0. If this is true, then either this factor is equal to 0 or this factor, 4x minus 5, is equal to 0. And then we solve each of these. How do I solve this equation? I'll subtract 3 from both sides, so I'll have 2x is equal to negative 3. And then I finish solving by dividing both sides by the coefficient of x, which is 2. And so I'll have that x is, I'll write that as negative 3/2. And this is or. How do I solve this equation? I'll add 5 to both sides. So I'll have 4x is equal to 5. And then to get x by itself on one side of the equal sign, I'll divide both sides by the coefficient of x, which in this case is 4. So the left side simplifies to x, the right side 5/4. Notice, once again, I happen to have two solutions. One solution is negative 3 over 2. The other is 5/4. And don't forget what we mean by a solution to an equation. A solution is, in this case, a number that makes this equation a true statement. In other words, if you let x be negative 3/2 here and here, a true statement results. If you let x be 5/4 here and here, a true statement results. And we'll check that, not this particular one, I'll leave it to you. We'll check an equation in a moment. Let's now look at some steps we can take to solve a quadratic equation by factoring. Step 1, write the equation in standard form so that one side of the equation is 0. Step 2, factor the quadratic equation completely. And here we are indeed solving quadratic equations by factoring, so we would factor a quadratic equation completely. Step 3, set each factor containing a variable equal to 0. Step 4, solve the resulting equations. And step 5, check each solution in the original equation. Let's go through those steps as we solve this equation. Now notice for a moment what we have. If we did multiply on the left side, that would be x times 3x or 3x squared. So we do have a quadratic equation. Now we have a factored polynomial on the left side, but the problem is we do not have 0 on the right side. So you may not set each factor equal to 14 or equal to 0 or anything else at this point. You've got to have a factored form on one side, 0 on the other side. So let's go through those steps. Remember the steps? It's write our quadratic equation in standard form by setting it equal to 0. So in our case, that would be x times 3x minus 1. I'm going to subtract 14 from both sides is equal to 0. then we want to factor the resulting polynomial on one side if it does factor. Now, first of all, let's multiply and see what we have, and then we can try and factor. X times 3x, that's 3x squared, minus 1 times x is x, minus 14 is equal to 0. So let's try and factor this trinomial. We are solving quadratic equations by factoring. We'll need 3x and x, and let's see if we can, if I put a 2 here, I know that's a 6x, put a 7 there. Okay, let's check, and don't worry if you need to take more time with factoring, there's no problem there. But let's see if I factored correctly. 3x times x is 3x squared, outer product is 6x, inner product, that's minus 7x or negative 7x. So 6x minus 7x is negative x or minus x. Last times last, negative 14, I have factored correctly. Notice what we have. We have a factored polynomial on one side, which we actually did before, but now we have 0 on the other side, which we must have. So our next step is to set each factor containing a variable, and these two both do, set each factor equal to 0. So 3x minus 7 is equal to 0, or x plus 2 is equal to 0. And now let's solve each of these linear equations. Here, I'll add 7 to both sides, so 3x is equal to 7. Then divide both sides by the coefficient of x, which is 3. And I have x is 7/3. Or here I just simply need to subtract 2 from both sides, and I'll have x is equal to negative 2. So it looks like we have two solutions. One solution is 7/3, the other is negative 2. Don't forget to check these in the original equation, and we actually will go through the check here one time for you. And that's how we solve quadratic equations, by factoring. So let's check. X is equal to 7/3. And then in a moment, we'll check negative 2. All right, how do we check it? Everywhere there's an x, we put 7/3. So that's 3 times 7/3 minus 1. Is that equal to 14? It better be, but let's check. So we have 7/3 times, what is 3 times 7/3? Well, 3 times 7/3, this is like 3 over 1, so those divide out, and I have 7 minus 1. What is 7 minus 1? That is 6. Is that equal to 14? Well, now I'm multiplying. You can multiply numerators and multiply denominators to multiply fractions, or we can see that there's a common factor of 3 here. 7 times 2 is 14. 14 over 1 is 14, and I have indeed checked. That is a true statement. 7/3 is a solution. Now let's check negative 2. To check negative 2, we do the same thing. Everywhere there's x, we replace x with negative 2. And we want to know, is that 14? Well, let's see. Working inside the parentheses, 3 times negative 2, that's negative 6 minus 1. Negative 6 minus 1 is negative 7. Is that 14? Well, yes, negative 2 times negative 7 is 14. Again, a true statement, so negative 2 checks. What does that mean? That means we have two solutions. One solution is 7/3. The other solution is negative 2. That's how we solve quadratic equations, by factoring.